second El Nino update. This is the official update from NOAA, from the Climate Prediction Center. We can see about 2 weeks ago, they declared El Nino. They basically said that the ocean and the atmosphere, in terms of the winds and the rainfall, convection patterns, and pressure patterns, were El Nino, like in the Pacific. These have strengthened definitely in the past 2 weeks, so I'll go over that. But even in early June, the CPC was saying it is enough to declare El Nino. And then in terms of strength, we see a strength probability about 63% chance of a super El Nino, or very strong, it's the same thing. And then a strong El Nino, almost a 90% chance, and then at least a moderate El Nino is virtually guaranteed. So, um, you know, the Climate Prediction Center, even back in early June, was very confident in at least a strong El Nino, and somewhat confident, especially for this time of year, in a super El Nino. And honestly, I would expect that signal to strengthen in July. So look at the most recent outgoing long wave radiation anomalies, and this is essentially a proxy for cloudiness and deep convection. If you have these blue anomalies, you tend to have more clouds, more thunderstorms. These red and orange anomalies indicate sunnier skies, less clouds, less rainfall, all that stuff. And for El Nino, you want less clouds here, so more. This would be more orange and red here, and depends on the time of year. But this time of year, you probably want your blues over the date line, over that 180. What we see is generally more blue here. The signal especially strengthens as you get forward in time, but more blue here we generally see, and we generally see more sort of red and orange over Indonesia. So this is what the OLR has been doing over the past. These are not exactly like weeks. These are like 10 days, maybe like no, these are like 9 days. That's like 3 9-day increments. So yeah, pretty El Nino like, but I also have the monthly signal, which is it's kind of cleaner to read. It's kind of easier to see, but even you see from this that there's definitely a more El Nino like signal in the OLR. And then if you also look at the the 200 zonal winds, which are you generally want, if you want El Nino, you want these blues, right? These blues indicate upper level easterly winds, which indicate a weaker Walker circulation, because normally in the Walker circulation at the top of the clouds, which is basically at the top of the clouds, you get the winds blowing from Indonesia to South America, so they're westerly. So if you have these easterly winds, that means that those westerly winds are weakened or reversed at the top of the clouds, which indicates a weaker Walker circulation. You can see this residual La Nina circulation that occurred in spring and in winter, causing these westerly anomalies, and then you start to develop the easterly anomalies in the eastern Pacific and the east central Pacific. So definitely a El Nino like signal here in the 200 zonals. If you look at the subsurface temperature, you can see it's still very warm, about 7 degrees above normal. Thermocline is extremely flattened. This 20-degree isotherm is really down from where it should be in the eastern Pacific, especially, and that is going to cause more warm water to rise. The only thing stopping this El Nino from strengthening would be an abrupt, the atmospheric coupling to just stop abruptly, and I don't really see that happening. It's a loaded gun kind of a setup here. I mean, you have really warm water. It's even warmer than 2015, and I think it's about as warm as 1997, but extremely warm. And look at the anomalous depth of the isotherm in the eastern Pacific. You can see it's like 42 degrees above normal, but this, it might be a bit higher here, because this is maxing out the scale. Like it might be a little bit higher. I don't know, but it's extremely deep in deep relative to normal in the Eastern Pacific. You can see it's starting to kind of back build here, with this like, what's that, 12 to 18 iso, anomaly isotherm, I guess, starting to back build. That is probably due to recent westerly wind forcing in the Pacific, and because I'm like upper ocean heat content, you can see that's starting to rebuild. That got to like a record high for that time in April after the westerly wind burst, and then do this sort of not easterly wind burst, but a relaxation of the westerly wind burst. That's where it went back down, and now it's climbed back up above 2, but very high OHC. So that's that. And then in terms of other observations, if we look at the sea surface temperature observations, we got OISST. We see is a very SST pattern is very favorable for El Nino. Obviously, you have your reds and your oranges here, your above average sea surface temperatures in the eastern and central Pacific. That's expected. But what hasn't always been the case in the recent El Ninos, and what's sort of maybe stopped them from coupling as well as they should have, is the warmth in the western Pacific. And that is not really the case this year. There is, the western Pacific is cooler than the rest of the tropics, which is important for El Nino development. It can help suppress convection over Indonesia, over the maritime continent, which in turn favors weaker trade winds and more warming here. So it's a pretty El Nino favorable pattern. And if you look at the mean SST, we can see that the warm pool has migrated pretty much past the date line, which is pretty unusual for this time of year. It's a very eastward shifted warm pool. So deep convection right now is favored over the date line instead of Indonesia. It's very El Nino like. And then you can sort of see this in the ENSO longitude index, which I believe measures the sort of mean warm pool, the center of mass of convection. You can see it's been sliding eastward into a more El Nino friendly territory. At this point, I don't know what this year is. Maybe it's 1997. But at this point, it's further east than a lot of the other El Ninos, and certainly further east in climatology. So it's a pretty eastward shifted warm pool, if you will, which would generally help convection shift east. Look at the actual SSTs. They're generally moderate territory. They've been in moderate territory for some time now. This one's edging towards strong, but it's not strong yet. I think it'd be strong pretty soon, given the from the wind forecast, but it's not strong quite yet. But it's about moderate right now, and I think it's moderate in the atmosphere too. Maybe it's a bit stronger in the atmosphere, but it's not gonna be a super El Nino yet. And then if we look at the current analysis and 30-day 850 zonal winds, what we see is this pretty significant westerly wind burst in the central Pacific near the date line. I don't know if that's like 15 knots, maybe it's a little less. It's like 13 knots. I don't know the exact value of it, but it's decent, right? It's a decent westerly wind burst. That's going to cause more warm water slosh east, more warming of the central and east Pacific, and something to raise the odds for a super El Nino. If we look at 200 zonal wind, which I showed earlier, but this is sort of a 30-day average. You can see upper level easterlies. Again, that's a pretty classic El Nino signature. And then pressure. You see high pressure over Indonesia, and your normal pressure over South America, or near the coast of South America. Now, ideally, you want low pressure here near the coast of South America, but because you have high pressure here, and because the trade winds are weakened, and because of this, and because a bunch of other things, I'm not really concerned about there not being low pressure here. I think El Nino is still well coupled. Ideally, you would have it, but it's not like the biggest deal. And then We've got velocity potential, the 30-day average. You see sinking motion, upper convergence over the maritime continent and Indian Ocean, and then upper divergence over the Pacific, essentially east of the date line. That is also El Nino, sort of El Nino like. So this is all painting the same picture. Everything's El Nino like. El Nino is definitely coupled to the atmosphere. I think it's quite strong too. In terms of everything I'm seeing. If we look at the OLR on terms of a monthly average, what is it? This is what you get. So you get pretty significant suppressed convection over Indonesia, pretty significant enhanced convection over the dateline. Now, in terms of all this, it's important to note that these sort of anomalies, even though they're all pointing in the direction of El Nino and they're pointing towards a strong El Nino, they could be influenced by the MJO, right? Like, I don't think this is purely MJO induced, but these might have been enhanced by the MJO or other sort of subseasonal equatorial waves. But I still think it's at least like a moderate El Nino signal. I don't know if this is on its own is a strong El Nino signal. That's the OLR. Get the SOI. It's also negative. It's been rising up a little bit recently, but it's still negative. The 90 days in El Nino territory, the 30 days in El Nino territory. The 30 day is going to be in El Nino territory now for 3 months, because June is not going to end up below or above -7. And we got the daily contribution. It went positive for a little bit, but now it's gone back solidly negative. So the SOI, maybe it's rising a little bit, but I'm not concerned about it. Like, I don't know, it's gonna go positive all of a sudden. I wish we had the equatorial SOI, which in my opinion is better. I don't know why we don't. Don't ask me, but yeah, it's just have to deal with the regular SOI. And then look at some of the Hogg-Muller diagrams for the forecast. So I've been looking at observations for so far in this video, but if you look at the sort of forecasts, you see in the EPS model, which I would say is the best model, we see a continuation of the westerly wind bursts in the EPS model. This will almost undoubtedly cause more warming, more Kelvin waves, more convection in the central Pacific, because westerly wind bursts tend to favor more convection in the central and eastern Pacific. In addition to the warming of the waters there, it's also the wind patterns that favor more convection. But yeah, it isn't continuation of the westerly wind bursts. It trended a bit weaker since the last run, but it's still relatively strong, and it's over the dateline mainly. And we also have a strong one going on right now. So generally strong westerly wind forcing in the Pacific, and mean convergence is going to be over the dateline. That's important. That's going to encourage convection there. You look at the 200 zonal winds. We see also more upper level easterlies. So that is going to indicate more El Nino potential, and the velocity potential, a lot of negative velocity potential over the central and eastern Pacific. So all of this is, it's very El Nino favorable. The conditions for El Nino will continue to grow, I guess. I don't know. Now, if you look at the long-range forecasts from the European weeklies, we see a very standing wave-like pattern. This is probably underdoing the subseasonal influence a bit, in my opinion. For instance, we see this sort of weakening of the greens here. It's kind of hard to see, but you can see this contraction of the sort of green anomalies. That's probably being underdone. So this will probably not be used. You can sort of see this one continuous stripe of green. I don't think that'll actually be the case in the verifications. In my experience, this model tends to underdo subseasonal influence and overdoes enso influence, because I think a lot of the subseasonal influence probably gets maybe smoothed out by the main but every member agrees El Nino is going to influence the pattern. It's sort of my theory about it, but I don't know if it's true. Um, but yeah, but I mean, even so, the model is saying it's going to be an El Nino like pattern. So there, it is favoring El Nino, but I think maybe the extent to it is a bit overdone. Look at the zonal winds. It's sort of the same thing. Like, it's predicting a lot of westerly wind bursts. I think those will happen, but I don't think it's gonna be this one continuous thing of westerly wind bursts in the Pacific. Now, last thing we'll look at is the European AI model. Go here to the world. You get the precipitation anomalies, for example. We see generally enhanced rainfall near the dateline, suppressed rainfall near Indonesia. So El Nino like in terms of that. And then if you look at if you look at the velocity potential, also a lot of upward motion in the Pacific, not as much in the Indian Ocean. So the models are pretty, they're pretty not unanimous, but the two main ones I would look are the European AI and the European are pretty El Nino like. If you look at the trade winds, which these westerly anomalies are going to be overdone, by the way, slightly, not by that much, but even so, you still see these very strong, 14 knot westerly anomalies in the central Pacific, and that is unsurprising considering the base hit that we have, and considering the convection pattern, the sort of rainfall pattern that's forecasting. This model is forecasting, which would be very favorable for westerly wind bursts in the Pacific Ocean. So that's the European AI model. Let's look at the pressure, and that is also El Nino like. So a very El Nino like response from the European AI. Got the European. That one's not available, but the runs aren't going to change that much. We'll see in the pressure, which wasn't on the Hofmüller for the EPS, is also El Nino like, and the rainfall is too. So the point is, the observations support El Nino in terms of the coupling, the models for El Nino, everything supports El Nino. I think a super El Nino is likely. Uh, RNI, an ONI super El Nino is pretty much guaranteed, and RNI El Nino I think is likely. I think the real question at this point is whether or not it'll reach historical strength in the RNI, which would be 2.5 C RNI, which occurred in 82, 83. Do I think that'll happen? Maybe there's a 50-50 shot of it, but it's a very impressive event. So that's all I have.